Hello, I'm Philip Russom. I'm Research Director for Data Management at TDWI, the Data Warehousing Institute. We're here at a TDWI conference in San Diego, and with me is John Myers. He's the Senior Analyst for Business Intelligence and Data Warehousing Practice at analyst firm Enterprise Management Associates. John, how are you doing today?
Doing well, sir. Thank you for having me.
Yeah, it's always a pleasure to see you. Listen, John, I understand you're teaching a course here. Can you tell us a little bit about that?
Yeah, it's the TDWI Data Virtualization course. Its subtitle is Solving Complex Data Integration Issues, and it's we've had some good success with it. It's a way of taking a look at data integration that's a little different than the traditional way of approaching it.
Very good, and yeah, that's great. Our audiences are typically keen to learn new methods because they're all struggling with new data types and new business requirements around us. So since you're teaching a course on data virtualization, I thought it'd be great to get you in here as an expert to just talk about what it is, what it's for, what people are doing with it. So why don't we just start with that first one? Can you give us your nutshell definition? I know it's hard. Data virtualization can be a lot of stuff, can't it?
Well, I think when you talk about it from a technical implementation, you can talk about many different variations of what data virtualization could be. But at its core is what it's trying to do is say, as opposed to a traditional ETL process where you physically move data from point A to point B, materialize it on a spinning disk, virtualization allows you the opportunity to utilize that as a data service without having to store that data. We find it's very effective in opportunities where you want to fail faster, to do prototyping, to develop requirements, more of an agile approach or a nimble approach, if you will, because I'm not a huge fan of capital A agile, but love little a nimble. But it's basically the ability to integrate your data sources the way you would in a material fashion of ETL, but you do it in a virtual fashion over the network and make it available that way.
That's great, and that is kind of an alternative practice. Those of us in data warehousing and BI, we've gotten into that habit of ETLing the heck out of data to improve it and get it ready for the warehouse with these a priori data models we worked out. And that takes a lot of time, and then things change, don't they? And all that hard work has to be redone. So you mentioned agile. Do you see virtualization as something that enables a more agile methodology?
I think it definitely enables agile and a quicker time to implementation. But I also see use cases that are very good for doing the materialized side of things, because there are times when there are use cases where you want to make sure you have all those pieces that you have from a materialized view for ETL. But data virtualization gives you that opportunity to say, if we are prototyping, if we're doing something that might be only up and running on a quarterly reporting basis or a regularly scheduled report, but we're looking at it, again, not on an all-the-time basis. You can use it in that area. You don't have to provision the hardware and the bandwidth and the things that you need on a regular basis for ETL. But it's also things you can use every day, because the processing power in our systems, the bandwidth in our networks allow us to move a lot more information through the environment and allow us to manipulate it in a much faster time frame.
Yeah, all those are very good points, especially towards the end there. You said systems nowadays can actually do this. You know, we tried, it's funny, a lot of things that we're actually doing today, we tried in the 90s, but the systems weren't fast enough. So this kind of virtualization was just terribly slow in the 90s. Do you agree that today the systems have the speed?
I would definitely agree with that. One of the things we talk about in the class is a timeline of some of our analytical or EDW technologies. And I think that we hit some very nice inflection points over the last couple of years, both in terms of processing architectures with MPP coming online, the new abilities of in-memory platforms, and particularly external to that, the bandwidth available to us in networks, things that we're able to move a lot more data than we used to be able to a lot more reliably.
That's excellent, and I occasionally find people who said, yeah, we tried virtualization, but it didn't work, but that was 10 years ago. So they should take another look at this.
I would definitely say that there are new cases that are open. The existing ones can now be reopened as well.
Speaking of cases, you've already given us some good examples. I see virtualization getting used a fair amount around analytics, and we have to remind people analytics and reporting have different data requirements. So for reporting, you typically do want squeaky clean data, carefully modeled with a airtight audit trail, stored ahead of time in the warehouse. You know, all the stuff we've been doing for decades. But Analytics typically is more open-ended. It's faster. You're never quite sure what your sources are. You want to be on more of a discovery mission as opposed to reporting that's all about data you know very well.
That is correct.
Do you think virtualization has a play in analytics?
I would say so. It goes back to that the agile approach, that nimble approach.
Yes.
Because a lot of times, you're exactly right. The things that we know, those are very easy to build out the requirements, go forth, lay it out, we're all set to go. The things that we don't know, or the things we know we don't know, or even worse, the things we don't know we don't know, you get into those areas, and then you want to say, you don't want to get locked in that, what I call getting wrapped around the axle of what do you need, what do you got, what do you need, what do you got, when you have the business guys being asked, okay, we want to do analytics. We're not quite sure which components are going to fit into it. IT goes, well, what do you need? And you reply back around the circle. With virtualization, you can enable things like self-discovery. You can enable just having an access layer to all your data sources so that you can now take a look into them and say, now we know what we want to do, cycle through that much faster and figure out the things that you want to know.
Excellent. Great examples there. Before we close, can you take a look into your crystal ball? Where do you think the practices around virtualization are going?
Well, I think that in the future we're going to continue to see improved performance for the data virtualization platforms with the continued implementation of MPP architectures, improved in-memory processing, and of course the improved networks. But I also think we might find people moving to a continuum of materialized ETL and virtualized data services so that people can make decisions not on a, hi, our company is going to do this, but on a project-by-project basis, and make those decisions based on a particular problem and the particular use cases they have to implement.
Excellent, excellent. I look forward to that future.
I do as well.
So folks, in closing, again, I'm Philip Russom, TDWI Research Director for Data Management, and I'm here with John Myers. He's the Senior Analyst for BI and Data Warehousing at Enterprise Management Associates. Thank you so much for joining me today.
Thank you very much, sir.